Using the carbonic acid buffering system to understand how our blood can handle increased amounts of protons as well as base. Let's first start with what will happen if we have excess acid. So in this first example, which I'll draw in red, something has occurred that has caused an increase in the amount of proton to be added to the system. Increased acid. In this scenario, the increased acid that is added will respond and react with present bicarbonate ion. Because you have these two species coming together, you are going to make more carbonic acid. If you make more carbonic acid, you now have more carbonic acid available to dissociate into carbon dioxide and water. By looking at this equation, you will see that adding acid increases the number of species that you have here in the equation, so it's going to drive the overall reaction to the left, increasing the concentration of CO2 in the blood. Physiologically, you can increase your respiration rate to handle this excess CO2, get rid of CO2. So now let's look the other direction. We've now added base. If we add base, we have to think of this more in a two-step process. So any base that's added must react with acid that is present. That will give us a non-reactive species of water that won't harm us, plus some bicarbonate. So this is step one. Now I've had excess bicarbonate put into the system. So now I need to do something to handle this larger amount of bicarbonate. Using the original reaction, if I'm going to have something to react with this bicarbonate, I'm going to use some of my acid. By using the acid, I am going to have to pull from the carbonic acid. The only way I can end up with protons to react with the bicarbonate is to use the carbonic acid. So now I've decreased my levels of carbonic acid. I'll need to make more of it. So to do this, I will need CO2 and water. This is going to drive my overall reaction to the right, thereby decreasing the level of available CO2. So you can now slow down your respiration rates, allowing you to keep more of your CO2 so that you can continue feeding this reaction to the right.